Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Hello and welcome to Lost in Science for another week. This is another half an hour of some of the best mind-blowing science that you're going to get on your radio. And who am I? Well, my name is Claire, and with us this week is Dr. Matthew Snelson. Matthew is from the Monash University and is a researcher exploring how diet can influence gut health and how these are linked to chronic diseases that, of course, you've heard of: hypertension, diabetes. These things affect millions of people. But Matthew's research is pretty interesting, getting an idea about what the link is there between what is actually going on with our gut microbes and how that's affecting the rest of our body and the way that we're responding with inflammation. And also on the show this week, we are going back into the archives, back to 2022. Was it a simpler time? You tell me. But it was a time where Chris took us on a deep dive through all the space junk that is orbiting around the Earth at the moment. And, tells us what it is, who is putting it up there, but also what there is in the way of space laws out there. Making sure we are keeping safe from falling satellites. I definitely do not want to be hit by a satellite. That would be a dumb way to die. Anyway, gut microbiomes and space junk on the show today. Let's get on with it. So chronic diseases like hypertension and diabetes affect millions of people worldwide. These health conditions are often linked to our diet, but there's more going on beneath the surface than just what we're putting into our mouth. And research is now suggesting that our gut health has a crucial role to play in managing these diseases. Now, to help us understand how it's all connected, we're joined by Dr. Matthew Snelson from Monash University, who is exploring how diet can influence gut health. Matt, welcome to Lost in Science.
Oh, thank you so much for having me, Claire. Super excited to be here.
Oh, we're excited to have you. And, we hear so much about gut microbiomes and leaky guts, those sorts of things that I guess are concepts that feature quite a lot in your research. But can you break them down a little bit and tell us what they actually mean? How they relate to chronic disease.
Yeah, absolutely. And it's certainly an area that I never envisioned myself being in when I started down this route many years ago. I was always interested in diet and how it affects chronic diseases, like you were mentioning at the start there. And then we learned more and more about the gut microbiome. I'm like, yeah, I'm going to learn all about the gut microbiome because I know diet affects that, affects the bacteria that live on us. We know a lot about that and how that can be linked to health. And as I got more and more into it, I started to find out about this concept of gut permeability or leaky gut. And that is the idea that our guts have a really important role. Well, they've got a lot of important roles, really. They help us to absorb all the nutrients we need from food, absorb all the water. But then those bacteria that live inside of us, we actually want them to stay inside our gut. We don't want them or any bits of them crossing into our blood. And I like to think of this. Oh, yes.
It's sort of mind exploding to think that they can. I just assume they stay put.
Well, yeah, and that's where they should be staying most of the time. And our bodies are really good at fighting if any bugs do get into our blood. So you have a fall over, you cut your arm a bit, there's going to be some bacteria that are just living on your arm, living in the environment. They're going to get in there, and your body's going to mount an immune response. It's got all these immune cells that are going to get onto it, get there, kick that bacteria's ass, and get it out of there. Um, Immune system's really important for that, and that's really good, that acute inflammation, to get rid of things like that. But the issue is if we have constant influx of bacteria or parts of bacteria into our blood, we get this chronic immune response. The inflammatory cells are going into overdrive all the time, and that's not great. And that's what we're seeing in all of those chronic conditions, that chronic immune activation. And where the gut comes into it, and this idea of leaky gut, the guts are big. I don't know if you know, like I remember when I was a kid, there was a place called SciTech in Perth, a bit like Science Works in Melbourne. And they had a display where it was a mannequin of a person, you could pull the guts and pull it back to see how long it was. I think it was like, 7 or 8 meters or so long. So the guts are pretty long.
They're
But what I
long.
find fascinating is they've got a huge surface area, about the size of a studio apartment, inside
Wow.
your guts.
Wow. Oh, so they've got a lot of folds, I imagine. Because
Exactly.
I mean,
Yeah.
otherwise there's a Mary Poppins situation going on inside all of us.
I do love that image now. I'm going to keep that with me, that image of us having a Mary Poppins like inside of us. But you're right, particularly the small intestine, there's lots of folds, things called villi. But across that surface area, most of the time, and our guts are really good at keeping that surface impermeable or not very permeable. But if we do get some breakdown of the barrier there, then parts of those bacteria can cross into our bloodstream, and that's where we get
Mm.
that chronic inflammation. And we see that associated with different things in the diet, for example, and different health conditions. And that's the thing that I'm really interested and looking into at the moment. If it's this leaky gut, this gut permeability that might be linking our diet and our gut microbiome to these health conditions that we're seeing.
You sort of initially got into it from a nutritional point of view. So can you tell us a little bit more about that journey that you've been on with your research?
Yeah, it's been a journey. You're absolutely right. And I find it interesting the way, science can take us in all these different directions. When I went to uni, I originally wanted to become a food technologist. I always said, oh, I'm going to be the person to make the next Nutri-Grain. Or if we can't say branded products, I'm going to be the person to make the next processed three-hold cereal out there. But during that journey, I got more interested in health and how diet can affect health. I trained as a dietitian and worked clinically as a dietitian for several years in hospitals in Perth. And that's when I got really interested in the science, nutritional physiology behind it, and pursued a PhD, got interested in the gut microbiome, and now I'm interested in how leaky gut and that how important the guts could be. So again, from the kid who wanted to make Nutri-Grain to where I am now, it has been quite a journey.
Yeah, just to go back to this, to sort of the leaky gut, what are the factors that influence, whether you have a leaky gut or not? And what do we know about that?
Yeah, and so it's a really early area of research. I almost sometimes shy away from the term leaky gut because it's not properly defined. We can't say to a person, you have a leaky gut and you don't. In the future, we might get to a point there, but at the moment, we really measure just how permeable their gut is, and then we can sort of look at it compared to other people.
Mm.
The factors that can affect it that we know about, certainly diet is a big component of it, particularly more processed Western diets. There's some evidence to say, for example, the things that like emulsifiers that we have in the diet, from mouse models at least, can affect how permeable the gut is. We know certain conditions. So if you have kidney disease and your kidneys aren't able to get rid of urea as much, you're not able to, get out of that, flush it down the toilet, that's actually able to move into your gut, where certain bacteria are able to break it down to ammonia. And ammonia is very caustic, and that can actually affect the tight junction proteins, which help to keep the cells in our gut nice and tight together. So certainly health conditions can affect it. We know diet can affect it. We're trying to look now if there are particular bacteria as well.
And just from a scientific point of view, how do you measure, gut permeability? What are you actually doing, and how do you do it? Have you done it on yourself?
Great question. And there are so many different ways to do it. I have measured my gut permeability many a times. So the way the things used to be done, and sometimes still are done, is where they would take an endoscopy, so get an actual sample of the tissue in the gut, take a little chunk out, put it in a chamber, put something on one side of the chamber that's a little fluorescent molecule, and see how much ends up on the other side. Now,
Right.
I haven't given myself multiple endoscopies. There are more different methods that we can use that are less invasive. The way that I'm doing it in my study is we have a solution of different size sugars that people are able to drink. So some of them are smaller size, some of them are bigger sized. And as those sugars go down, these are non-absorbed sugars, by the way, so they don't normally get absorbed. What they're able to do is if there is a gap between the cells, if the barrier there is permeable, these sugars then able to pass from inside the gut through to our bloodstream. They get filtered through the kidneys, and then we can measure them in the urine. And the really cool thing about that is, depending when you collect the urine, you can look at different parts of the gut to see which part of the gut is permeable. So it's a really
Mm.
nice, non-invasive way. Something that I've been happy to do on myself multiple times, which I would not say for an endoscopy.
Yeah, wow. So gut permeability can change across time, but it can also change depending on what part of the gut you're looking at.
Yeah, so definitely we know that the gut permeability of different parts of the gut, different sections of the gut, and by sections I mean like the small intestine versus the large intestine. As for how it changes over time, we don't know a heap about that. It's something that I've been really interested in. Part of the reason I wanted to test it myself multiple times,
Mm.
including one time, I decided after running a stupidly long distance, a few days later, I thought I'll test it just to see if there's any changes. What have I done there? Because there's certainly been some research where people have assessed gut permeability during these ultra endurance events, and people do have leaky guts during the event. And I was like, kind
Mm.
of curious to see if I'd have one a few days later, but I was back to normal, which
Oh,
just shows
good.
how quickly our gut's able to adapt and heal.
Indeed, indeed. And tell us a bit about the research that you're undertaking at the moment.
Yeah, so I'm working at the hypertension research lab at Monash Uni, and I'm really interested in this idea of gut permeability and how it might be important for our blood pressure regulation and in the context of hypertension. So we know that hypertension, it's an inflammatory basis to it. Inflammation's involved, but we haven't really looked that deeply in people to see if there's a link between how permeable the gut is and blood pressure. And the thing that I'm really curious about as well is how it relates to our overnight blood pressure. We kind
Mm.
of think about blood pressure. We go to the GP, we get our blood pressure monitored, but it's coming out more and more that it's actually that overnight blood pressure that's really important. Normally,
Right.
you'd think that well, the general idea is that overnight, blood pressure goes down a bit. It gives us our bodies a chance to recharge. Our organs get a bit of a rest. But if it's constantly high, you've got this constant amount of pressure. It's like you've got a car and you're revving it constantly everywhere you go. It's not going to be good for the engine. It's not going to end up well. And that constant, high blood pressure at nighttime is actually more predictive of having a cardiovascular event than during the day. So what I'm looking at is how overnight blood pressure, and as well as during the day, how this relates to gut permeability.
And I understand you are looking for some volunteers for some of your research. Is that right?
Yes, if you'd like to come along and take part in our wonderful scientific process, we're looking for people with normal and high blood pressure. Pretty much anyone's welcome to come and take part in it. You get to learn quite a bit about yourself in the process. One of the things that we do that has really captured people's attentions is we measure how long it takes for food to get from the mouth to the other end, and we do that with very, very brightly blue muffins. They're just regular muffins with a high amount of food coloring in. You could have a similar effect going to a kid's birthday party. Maybe you'd notice some color change happening a day or two after.
Being a mother of a small child who enjoys blueberries, I'm well acquainted with the length of time that it takes for a blueberry to go from one end to the other end.
It's interesting when we were getting this trial together, I was sort of preparing and testing everything. I did make up a batch of these blue muffins at home, and the kids were really interested in them. So I'm like, of course, they're just regular muffins. They happen to have a bit of blue food coloring. That's all fine. A couple of days later, get a call from childcare being like, we just thought we'd better let you know about something.
The research is taking place in Melbourne. Is that correct?
Yes, we're taking place based at Monash University, but out of the Victorian Heart Hospital. It's very close to the Monash University Clayton campus.
Yeah.
But if people are interested to find out more, you can look up Hyper Trial. It's hypertension and permeability. I was very happy when I came up with that. Just Google Hyper Trial at Monash University, or look at us up on Facebook or Instagram, or you can email hyper@monash.edu, and we'd love to have you involved.
Well, Matt, that sounds like a very worthy cause to have a delicious blue muffin and learn a little bit more about your gut microbiome. Definitely, you should return to Lost in Science once you do the research and tell us what you find out.
I'd love to, Claire, and thank you so much for having me on. It's been a pleasure.
I think we're lost.
We're not lost.
Not even any short-range radio signals yet?
Except for a single, very powerful radio emission.
Of course, a transmitter of that sort isn't exactly standard equipment.
Science and technology must be absolutely mind-boggling.
Of course, it's mostly on the theoretical side.
Well, so far.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
Yes, you're listening to Lost in Science, and look, I'm fairly old. I think we've established that on here. And when I was a kid, I remember when Skylab came down. Do you guys remember Skylab?
I remember that.
For people who weren't born around the same time.
Skylab was the first American space station. The Soviets had space stations before then. This is the first American one, and it was pretty cool looking. It was kind of this, big kind of cylindrical thing, but with windmill-shaped solar panels. And as a nerdy kid, I loved to read books where they talk about Skylab and think that there was this space station up there and people doing experiments and stuff like that. So yeah, it was a pretty cool thing to have up in space, but of course it didn't last. And in 1979, it what they call deorbited. It came down.
It fell down.
It fell down, yeah. And it was a big
intentionally or
sensation.
non-intentionally?
Intentionally, and it wasn't going to stay up there forever. But I mean, it was uncontrolled falling. So they tried to aim it as best they could, but no one knew exactly where it would land. And this was obviously big news, international news, and as a young kid at that time, it was terrifying. I remember going outside and looking up and imagining, is this thing going to land on my head?
Yeah, of course.
Is it going to crash into your house?
Exactly. Of course, it didn't actually hit anybody. But some of it did actually come down in Australia. And ultimately, the Shire of Esperance in WA gave NASA a $400 fine for littering.
Really?
I remember that. And also there was radio stations giving away prizes if anyone could get a bit of Skylab and bring it in.
Yeah.
And I remember we were, every time we'd go outside, we'd look for bits of things that could have been, is this from Skylab? Is this from Skylab? But no.
So you can make a bit of money.
And did it end up sort of scattering across the globe, or?
Yeah, most of it was in the Indian Ocean. But yeah, some of it landed in Western Australia as well. So they're kind of aiming for a bit closer to South Africa, but yeah, it fell short a bit. But that was kind of the most kind of famous event. But it's happened before, and it's like I guess this the way this happened shows the difficulty in controlling these things and also keeping the people who launched them accountable for these things coming down. So under
Are you saying that a $400 fine, Australian dollar fine, isn't keeping NASA accountable?
Well, okay, so under international space law, it states, I love the fact there is such a thing as space law.
I do. I'm learning so much tonight.
A launching state shall be absolutely liable to pay compensation for damage. Now, as far as I can find, this law has only been applied once when, in 1978, a nuclear-powered Soviet satellite came down in a remote area of Canada, and they sent Russia the bill for the cleanup, essentially. So that's only the time that, like I said, I find this is, these liabilities being applied, but there's actual happening more and more that things are coming down. So apart from the recent strikes in Australia that I discussed in the introduction, in May 2020, there was some wreckage from the 18-ton core stage of a Chinese Long March 5B rocket that hit 2 villages in the Ivory Coast and caused damage to buildings. Again, didn't hit any persons. And also, recently, there's another Long March 5B rocket that was allowed to an uncontrolled fall towards the Philippines. That I think might have just landed in the water, but it was kind of getting very close to the islands there. So, this is happening more and more. And a recent paper published in the journal Nature Astronomy calculated the risk based on current practices and what we know of the discarded rocket stages that are currently in a low Earth orbit. So, these things, satellites are launched by rocket. The rocket usually kind of stays up there for a bit until it comes down. So they looked at the numbers of objects, where they're orbiting, and the world population distribution, and calculated that there is likely to be a 10% chance of one or more casualties over a decade, which doesn't sound a lot. That was a 10% chance of one or more people being killed by a rocket over the next decade or so.
10% is not really a small number, though, when you're talking about
probabilities. It's not. But I think the thing here is who is being put at risk and who is actually causing the risk. So due to the nature of the orbits of these rockets, it's mostly areas close to the equator that are going to be affected. That is like countries in what we call the global south, which has been, I think, misreported a little bit. I've seen some reporting that says it's the southern hemisphere that we're most affected. I'm misunderstanding the term global south, which kind of refers to the countries who are not the northern altitude countries, which is where most of the world's wealth is concentrated. But it's basically the same old story of the developed world dumping their problems on the developing world, essentially. And, I think that now that Australia has started to launch rockets from our territory, we basically count ourselves as one of those launching countries. And so we're not the innocent party here either. So it's not surprising that there hasn't been a great reaction from some of these launching countries. There was I found an article in the South China Morning Post which talked about this. Now, this is a Hong Kong-based publication that has more recently been accused of becoming more pro-regime. It had a striking claim. First of all, I said the chance of humans getting hurt is infinitely close to zero, which is mathematically questionable way to put it, I guess.
Yeah.
But they went on to say, they quoted Harvard astrophysicist Jonathan McDowell, the probability of a rocket hitting a person after it falls to Earth is just 1 in a few billion, which sounded very different from our other calculations that I quoted earlier. So I wondered about this and I looked it up and I found a number of statements from Jonathan McDowell talking about this kind of risk. And what it seems, he's talking about the risk to an individual person. Me with Skylab. So essentially, if you take that early calculation, that there's a 10% chance of someone getting hit. He's saying, well, there's 8 billion people in the world, so you've got like a 1 in 80 billion chance of being hit. So that's the number that they're using, and he's quoted that figure quite a few times.
That's
and they
quite
have put that
different when you think about how many people there are in the world.
Exactly. But I think a few people also are falling for this kind of arithmetic switcheroo.
Uh-oh.
So look, it is a problem. And there are standards that launching countries are meant to follow, but they're either very vaguely written or, as is often the case, I think in America, they're often waived due to the extra expense. It's just too difficult to reduce your risk. Some of these measures include things like, saving fuel for a controlled re-entry and then aiming at an empty area of ocean. So, for instance, a popular place is Point Nemo, as it's sometimes called, in the Pacific Ocean, which is 2,700 kilometres from the nearest land. 2,700 kilometres is the distance basically between Melbourne and Perth. It's a long way from anywhere, and it has become a very popular spacecraft graveyard. Of note that it is close to where H.P. Lovecraft located the hiding place of Cthulhu in his stories. And we're dropping rockets on it.
I mean, we can get back to Cthulhu, but have we gotten better at bringing crafts down than we have been in the past with like Skylab?
Well, certainly the technology is there. We have better accuracy at controlling flying objects, I suppose. The trouble is that it's the cost of doing it. So you've got to save fuel, you've got to carry some extra fuel up with you. Plus, they often like to use that extra fuel to get the satellite a little bit higher to its destination. So it doesn't have to have its own fuel to get where it's going. So you're kind of asking people to spend a little bit of money to be good citizens. And that's a bit hard when they're not the ones who are going to be affected by it. There's also the possibility of reusing rockets. You might have seen SpaceX with their landing rocket. But the recent debris that came down in Australia was from SpaceX, has been identified. And with the volume of satellites they're going to be launching, with their kind of swarm satellites, there's a lot more rockets and a lot more debris coming from SpaceX, even though they are developing the technology to reuse rockets. There's going to be a lot of non-reused rockets coming out from them as well. But there's other risks as well. Even the satellites themselves pose their own risks. So there's another recent paper published in the journal Earth's Future, which talked about how objects, when they're re-entering the atmosphere, release chemicals that can further deplete the ozone layer. And the rockets, when they're up at those high altitudes, release soot that contributes about 500 times more to global warming per mass than surface emissions. So we're basically polluting the upper atmosphere, and we are dropping things on the Earth. So yeah, look, I think that yes, your individual risk is still very low. It is several billion against you being hit by something. So you don't need to be worried like me with Skylab. But this, as I said, this is a risk and other sorts of pollution and danger that is not borne by those creating it, and they should be held accountable.
All we have this week on another episode of Lost in Science. Thank you so much for joining us. Lost in Science is recorded on the lands of the Kulin Nations and the lands of the Jiringunj people, and is broadcast around Australia on the Community Radio Network with the kind support of the Community Broadcasting Foundation. If you would like to get in touch with us, we would love to hear from you. You can find us at lostinSci@gmail.com. You can find us on Facebook, where we are Lost in Science on 3CR. You can find us on all the best podcast places. Or you can tune in again next week wherever you listen to Catriona, Claire, Chris and Stu get Lost in Science.
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.